Hello, everybody, and welcome to lesson 4.2 about ellipses. So this is our second lesson in the conics sections unit. So let's get cooking talking about some ellipses. So what an ellipse is the collection of all the points in the coordinate plane such that the sum of the distances from the point to two fixed points, which are the foci, is constant. So what that means is if I put my pencil right here, so at this point P, if I take the distance from the focus to this point and then the second focus to this point, the sum of those two distances will remain the same no matter where I go. So if I pick another point, so the distance from this point to this focus, if I add it to this distance, the sum of these two distances will be the same as the sum of these two distances, and that will hold true for any point along the ellipse. So this is just a more kind of mathematical description of what we just said. So this is the distance between the focus and the point, the distance between the second focus and the point. That will remain constant if I add those two things up, no matter where I am on the ellipse. So let's take a look at some stuff that we can do with the equations of ellipses. So this equation of an ellipse is specifically for if it centers at the origin and it has axes. So it has a vertical and a horizontal axis that are along either coordinate axis, so the x or the y axis. So what the x and the y here are, these are just the variables x and y. Notice that for this ellipse, this is always equal to 1. And a and b down here represent the length of the major and minor radius. So whichever one of these two numbers is larger will be the major radius and will indicate that the major axis is in that direction. And the smaller number is going to be the minor radius, and it'll indicate that the minor axis is in that direction. So down here, just two examples of what these could look like. So this one is an example where the major radius will be along the x-axis. And so the major axis would be the x-axis, and then the minor radius would be the y-axis. The minor axis would be the y-axis. And then in this one, the major axis is the y-axis, and the minor axis is the x-axis. So the larger one is major, the smaller one is minor. So here are a few important things to know about the properties of ellipses. So the foci are always equidistant from the major axis, or always located on the major axis, and are equidistant from the center of the ellipse. So in this problem right here, if I have my major axis on the y-axis, then the foci are on the y-axis, and each focus is the same distance from the center. All right, the major and minor axes are always perpendicular to each other. So the major and minor axes will always be perpendicular to each other. And the vertices along the major axis are equidistant from the center, and the vertices along the minor axis are equidistant from the center. That doesn't mean that these two things have the same distances as each other, but along the major axis, the distance from, so in this distance from the center to a vertex, this measurement right here, this would be the major radius. And then if I go in the other direction, the distance from the center to a vertex along the minor axis, this would be the minor radius. All right, so let's take a look at a problem dealing with this. So whenever we're calculating the major, the radius, the minor radius, and the distance from the center to the foci, we can use this equation. So the major radius squared is equal to the minor radius squared plus the focus squared. And what focus right here refers to is the distance from the center to the foci. So that's what this means. And I'll make that a little bit more clear, distance from the center to the foci. So let's take a look at this example. So this ellipse has a center at the origin. It has a focus at -3, 0, and a vertex along the minor axis is 0, -4. So when I think about what this looks like in the coordinate plane, all right, so the minor axis is going to be the y-axis here because it has a vertex at, oh, sorry, wrong direction. I thought it said 0, 4. 0, -4. All right, it has a focus at -3, 0. So this is going to look something like this. And so if I want to find the equation of the ellipse, in order to find the equation of the ellipse, I need to know the major radius, the minor radius. I need to know the center, which this one is centered at 0, 0. And that information can help me fill out the equation. So the equation is x squared over a squared plus y squared over b squared equals 1. So I need to figure out the major and the minor radius. And I know in this case, I know that the x direction will be the major radius because if the focus is on the x-axis, then the x-axis here is actually the major radius, or sorry, the major axis. So I can use this equation up here. Major radius is equal to minor radius plus focus squared. So the minor radius is the distance from the center to this point. So the minor radius would be equal to 4. The distance from the focus to the center, I can tell from this right here, from 0 to -3, that distance is 3. So then to find the major radius squared will be equal to 4 squared. I'll do it in the order that we have up here. This will be 4 squared because that's the minor radius squared plus 3 squared. In this case, this is a Pythagorean triple. So then the major radius would be equal to 5. So now I can fill in this information. If the major radius is 5, that's in the x direction because it's on the x-axis. Anytime that your major axis is horizontal, then that radius will go underneath x. If the major radius is vertical, then the major radius will be underneath y. So in this case, our major radius, we have x squared over major radius squared is 25, plus y squared over the minor radius is 4. 4 squared is 16, and that's equal to 1. So this would be the equation of this ellipse. All right, so let's look at what we can do analyzing some of the equations. So we'll get to this problem in class and analyzing the equation. So this time I'm given the equation of the ellipse, and I want to figure out some stuff about it. So the first thing that I can tell is the center is 0, 0. And we'll look at what it looks like when the center is not 0, 0 in just a few minutes. The major axis, I can tell that 25, this is going to be the major radius squared, and it's underneath the x. So the major axis is the x-axis, but I also want to get used to the fact that there's actually an equation for the x-axis. And if I look at the x-axis, the equation for the x-axis is y equals 0. All right, for the minor axis would be the y-axis, which has an equation of x equals 0. So these x equals 0, x equals anything gives me the equation of a vertical line, y equals anything is the equation of a horizontal line. So now the only thing that I have left to find are the foci and the vertices. So from what I have up here, I can tell that the major radius, that says radius, the major radius is equal to 5, and the minor radius would be equal to 3, because that's the square root of each of these numbers. Remember, this is radius squared, and so is that. So the major radius is 5. So if I'm starting at 0, 0, then that means that I have foci at 5, 0 and -5, 0. If the minor radius is the y-axis, then I also have foci at 0, 3 and 0, -3. So this ellipse will look something like this. I'll try to draw it as best as I can. So this ellipse will look something like this. All right, so I have the vertices now. They're at -5, 0, 5, 0, 0, -3, and 0, 3. So then to find the foci, I can apply that formula that we just had. So that says major radius squared, sorry, let me go back a couple pages. Major radius squared equals minor radius squared plus focus squared. So in this case, our major radius is 5. So I've got 5 squared equals minor radius squared, 3 squared, plus x, or foci is what we're looking for. I'll just call it f squared. So this would be 25 equals 9 plus f squared. Again, we can probably recognize this as Pythagorean triple. So f would be equal to 4. All right, what that means is the distance from the center to each focus is 4 units. And the other thing that I want to remember is the foci are located on the major axis. So the foci will be at -4, 0 and also at 4, 0. So the foci are at -4, 0 and 4, 0. All right, so this equation, we're not going to do the entire thing because it's going to be the same kind of process we just did for the last one. But the first thing I want to notice about this one is this isn't really in the standard form that I want it to be in. And specifically, I notice over here, this is equal to 9. Our standard equation of an ellipse that we have should be equal to 1. So what we're going to do is we're going to take this equation and we're going to divide both sides by 9. Because if we divide both sides by 9, then it should give us 1 over on the right side of the equation. It'll look like something that I know how to deal with. So when I divide by 9, I get x squared plus y squared over 9 equals 1. So again, we're not going to do this whole thing, but what I can determine from this is that the major radius would be equal to 3, because that's the square root of this number right here. And remember, even though this is just x squared, we can think of this as x squared over 1. So then the minor radius would be equal to 1. And then again, identify your major and minor axis. So this time the major axis will be the y-axis, which is x equals 0. And the minor axis will be the x-axis, which is y equals 0. All right, so then I'm going to leave the rest for you to finish. We're going to do this in class as well, so you can find the other 3 things on your own. All right, so up until now, we were looking at ellipses that had their centers at 0, 0. And so in this case, we're going to look at ellipses with a center at HK, and it has a major axis parallel to a coordinate axis. So the major and minor axis are still perpendicular to each other. They're just parallel to a coordinate axis in this case. So here's one example where the major axis is parallel to the x-axis, which means the major axis will be y equals something. And then here's one where it's parallel to the y-axis, which means that it will be x equals something. So this is very similar to the first equation. The major difference here is that h and k are involved now, and it's just x minus h, y minus k. So let's take a look at what we could do with this equation. So in this case, I have a center, or an ellipse with a center at -3, 6. So again, I'm going to write out what the general equation looks like. This is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. All right, so I'm going to start filling in the information that I know. So I've got the center at -3, 6. This is going to be x plus 3 squared over something. I don't necessarily know what that something is yet, plus y minus k. This would be y minus 6 squared. And again, these numbers are coming from the center. This is the h, this is the k, over something, and then this is going to be equal to 1. So now I want to think about what this looks like. So I'm just going to draw myself a general ellipse. This will probably not be to scale, but I've got this point at -3, 6. I have one focus at 2, 6. So because the focus is here at 2, 6, I can tell in this case that the major axis will be this horizontal line right here, because remember the focus is always on the major axis, and the major axis will go through both the center and the focus. So actually right here, the major axis would be y equals 6. And I can tell that because it's going to be a horizontal line that goes through these two. And specifically, both of these have a y value of 6. This major axis will be y equals 6. And then it also has a vertex at -16, 6. So right here, this is -16, 6. So from here, I can figure out a few things. I don't know anything about the minor axis right now, but what I do know is the major radius. So the major radius is the distance from this point to this point. And I can tell if I look at that, that is 13 units. So the major radius is 13. I know the distance from the center to the focus from -3 to 2. That's 5 units, which means now I just need to find the minor radius. So I would set up my equation, 13 squared equals minor radius squared plus distance from the center to the focus squared, which is 5 squared. Again, we probably recognize this as a Pythagorean triple. So the minor radius is equal to 12. So now when I start plugging this thing in, what I also want to determine is if I know the major radius is 13, I need to figure out if that goes under x squared or underneath y squared. Well, if I think about this in terms of what it was relative to the axes, the major axis is this horizontal line right here, which is parallel to the x-axis. So if the major axis is parallel to the x-axis, then the major radius is going to go underneath the x value. So this major radius squared would be 169. And then the minor radius will be the other one, so that will be 144. So then this would be the equation of my ellipse. All right. So this last problem, we're going to get it into the standard form equation, talk about how we would get this into the standard form equation. And then I'm going to leave the rest up to you. We will also do this in class. So this one, again, is a little bit different because in this one, I have an x squared term, a y squared term, but it looks nothing like what I want it to look like. So what I'm going to have to do is I'm going to have to do the process called completing the square. So I've got 4x squared minus 8x. So I'm going to put my x terms together plus y squared plus 4y. I'm going to put my y terms together, and I'm going to get my constants on the other side of the equation. So I've got 4x squared minus 8x plus y squared plus 4y equals -4. So in order to complete the square, make my life a little bit easier, I'm going to factor the 4 out of this first x part. And then in order to complete the square, remember, I take half of this term and square it. So that's -1 squared. So that's 1. So I'm going to rewrite this as 4 times x squared minus 2x plus 1. I put a line right here to remind myself this was not already in the equation because I'm going to have to do something to the other side of the equation as well. And this is going to be plus, I'm going to group my y terms together just for convenience sake. This is y squared plus 4y plus, again, complete the square, take half of this and square it. So half of 4 is 2, 2 squared is 4. And this is equal to -4. Now, here's the reason I added the lines underneath here. I need to go back and think about, remember, this is an equation. There's an equal sign here, which means I need to go back and think about how to maintain equality on both sides of the equal sign. So if I put a 1 in right here, I added a quantity of 4 to the left side of the equation because this 4 outside the parentheses means that everything in here is being multiplied by 4. So I added a 4, and then I added another 4. So altogether, I added 8 to the left side of the equation. To maintain equality, I would need to add 8 to the other side of the equation. So now the reason that we completed the square is now we can write this in a form that we're more familiar with. So this would be 4 times, I would factor this. And when we complete the square, what I get when I factor is it would be half of this term is what I would be adding or subtracting to x. So this would be x minus 1 squared. If you need a review on completing the square, I can give you some resources to go to find that. There will eventually be a video in my Algebra 1 section. I don't think that it's there at this moment on November 9th, but there will be a video there that I will link once it is created for Algebra 1. So this is 4 times x minus 1 squared plus over here, half of 4 was 2. So then this would be y plus 2 squared, and this is equal to 4. So again, it's not equal to 1. So to make this look like a more familiar form and make sure that it's equal to 1, I would divide everything by 4. And I finally end up with my standard form of the equation, which would be x minus 1 squared plus y plus 2 squared over 4 equals 1. And now from here, I'm going to leave it up to you to analyze the rest of the equation. So that is it for ellipses. Today we talked about the general characteristics of ellipses. Don't just pass over that part. That's going to be one of the most important things for you to know is what the ellipses look like and the characteristics that they hold. We talked about the equation of ellipses, the properties of ellipses, which also kind of ties into the characteristics of ellipses. And then we also talked about analyzing equations of ellipses. So I hope you took some good notes. I hope you come to class ready to learn, and I hope you have a fantastic day. I'll see you in the next video.